Okay. 9, 1, 2, and 3. So we need to read, interpret, conclude. That's pretty much what we're doing in this section. Let's take a look. Veggie burgers tend to be higher in fiber and lower in calories than a conventional burger. Their weakness, however, is high sodium content. Comparative information on veggie burgers is listed in the following table. Here it is. Which veggie burger is the most expensive, the least expensive? Well, let's just ask some questions, answer some questions. Which veggie burger is the most expensive? Well, sounds like they're not focused on the sodium or fiber or any of the actual content of the burger. They're really just looking at price right now. So which one is most expensive? Well, cost $101, $92, $105, $1. Looks like Veggie Burger C is the most expensive, unless I'm reading something incorrectly. We'll see. No, it's good. It is that simple. Everybody with me so far? Okay. And just as a quick note, clearly they're not arranged least to greatest or greatest to least. Okay, so just be aware. Which veggie burger is the least expensive? Well, I've got a 92-cent one and a 95-cent one. The rest are in the dollar range, so B is clearly the least expensive veggie burger. Good? So that first question had nothing, all the initial information had nothing to do with what they were actually asking about. Are we good? All right. Next question. Use the table to answer the questions. The table lists the basketball players in the IBA with the highest scoring averages at the start of the 2000-2001 season. Okay, so I guess this is some league, the IBA league, and we have the last names of these 6 players, number of games they played, points they scored, and therefore the averages would be points per game is what they're probably doing. So dividing, if you take the points and divide it by the number of games they played, that's probably how they're getting this number. Everybody with me so far? Okay. What is the difference in points scored between the player with the greatest number of points and the player with the least number of points? So, it almost seems as easy as it is. Let's take a look here. So, what is the difference in points scored between the player with the greatest number of points? Well, who has the greatest number of points? They're not ordered least to greatest. This is the greatest number of points, which is Harva. Now, so that's the greatest. The least number of points would be, here's 5567 is the least number, and that's Manuel, or Manuel, whatever. I don't know which way they want to pronounce that, but we got Harva and Manuel, one of those, okay? So what are they asking for? What are they asking for? Well, the difference in points scored. They're not looking at anything in terms of averages or games. They want to know between Manuel and Harva, what is the difference? So it's just a subtraction problem, right? That's it. That's all there is to it. Just a subtraction problem. I don't have a calculator with me right now, so I'll just do this in my head unless somebody wants to, not on my head, but on paper here, unless somebody wants to do it for me. But it looks like 4,401 points is the difference between Manuel and Harva. Okay, so 4401. Good? You guys get yours right? Any questions about that? Anything I can help you with? You good? All right, great. All right, use the pictograph to the left. Here it is. So it says, how many of the players at bats were singles? Well, take a look here, is that each one of these represent 2 at bats. So each ball means that there were 2 home runs here, 4 home runs here. Now, they're not concerned with anything other than singles. So every time there's a ball here, you have 2 times that a person was at bat. So I would presume that what they're asking you to do is look at the singles category in my problem. Yours might be different. Look at the singles category and count up the total number of at-bats for that. So remember that for this is 1, 2, 3, 4, 5, but this does not mean that you had 5. It's 5 times 2, which is actually 10. I think that's what they're going for. Everybody got that? Okay, so you gotta pay very close attention to the key. Any questions? Things I can help you with? All right, great. Let's move on. All right, the pictograph shows the approximate number of passenger arrivals and departures at 5 selected airports in a certain year. What is the approximate total number of arrivals and departures at City 2 and City 5? Okay, so I'm just gonna circle City 2 and City 5 so that we can just hone in on those. So, first question is the approximate total number of arrivals and departures at City 2 and City 5 is. So in other words, what you're going to do is combine this with this to produce that answer. Now, can't quite see it perfectly here, but each suitcase represents 10 million arrivals and departures. Okay? Each suitcase represents 10 million arrivals and departures. So if I have 1, 2, 3, 4, 5, 6 suitcases, then that means I have 60 million arrivals and departures there. You guys with me so far? Okay. If I have 1, 2, 3, 4 and a half, so I have 4 and a half suitcases times 10, because each suitcase is worth 10 and I've got a half here, then that is 45 million departures and arrivals and departures. The sum of that is what they're looking for, which would be 105 million arrivals and departures. Any questions about that? Make sense, everybody? Any questions I can help you with? You okay? All right, great. Let's keep on going. Okay. So the next one says the circle graph shows the cost of adding an art studio to an existing building. Find the total cost of adding the studio. Okay, so we've got multiple categories, right? Materials, electrical, all the way down to carpentry, and they've itemized these costs in this table. Is this pie chart really necessary in this problem? No, because they're not asking you about anything in terms of largest slice, whatever like that, and you could even actually determine that here as well. So all that's relevant in this particular problem is this itemized table. And if they're asking you for the total cost of adding the studio, what do you got to do with all those numbers? Add them all up. Now, I'm not going to do that. You guys can add on your own, so I'm not going to bother adding them up, but if you will simply add up all of your items in your itemized list, then you'll get the total cost. Everybody got that? You okay? Great, okay. Give you 30 seconds or so to finish up that problem. Of course, you're welcome to ask me if you have any questions. You okay? Good. All right. Number 6 coming right up. The circle graph is a result of surveying 700 college students. They were asked where they lived while attending college. Use this graph to find where most of these college students live. Choose the correct answer below. So, where do most of these college students live? Well, all you got to do you even really need the pie chart? Not really, because they tell you the size of each piece of the pie, don't they? Now, if they didn't tell you these numbers here, then this pie chart might be actually useful. But I mean, it's great to have it. And so, clearly, where do most of them live? At their parent or guardian's home, because 290 out of the total 700 live there, with the next highest being campus housing. So, I would presume that they're referring to the biggest piece of the pie, which is parent or guardian's home in my problem. Yours might be different. Got it? Questions? Okay, fantastic. Next, the circle graph shows the number of students at Rockford College who are enrolled in various majors. Find the ratio of computer science majors to business majors. Now, when they say find the ratio, what they're referring to is something A to B, which results in A over B. So, what is it? Computer science majors would be your A, and then business majors would be your B. Do you guys follow me? Okay. So that means that they're comparing CS, computer science, to B, business, And so when you're creating your ratio, you need to create it in that same order. You follow me? Don't put business majors on top, computer science majors on the bottom. If they say CS first, then it goes on top. They say business second, to business, business goes on the bottom. Follow? So you got to make sure you understand the order in which it's being described, that they want you to create your ratio in, and that order impacts your fraction. Okay, so with that said, CS is 1,800, and business is 4,000. And then from there, I believe they're going to want you to, just like they say here, simplify your fraction. I can cut off some zeros. That's 18 over 40. Divide that by what? 2, which is 9 over 20. Can I divide any more, simplify any more? No, it looks like that's it. So the ratio is 9 over 20. Now, if you're struggling a little bit with your fractions, completely understandable, but just make sure you get a little bit more practice with that. It's not too bad. We've done a little bit of this already. Okay? Anybody want me to do theirs? Questions at all? Okay, great. Let's keep on going. All right. In a survey, 1,500 people were asked which aspect of dining out was most important to them. The results are shown in the given circle graph. Use the graph to answer the following question. Of the 1,500 people, how many people felt that reasonable prices was more important than atmosphere? I'm going to zoom out so it makes it a little easier to see. So, how many people, so first, what's important? You got to know that there's 1,500 people involved in the study. That actually makes a difference here. Why does it make a difference? Because they've given you percentages. They didn't give you the actual number. They gave you percentages. So knowing how many people there are in percentages is going to give you an actual quantity of people per category when you multiply it. Okay? We'll get there. So which areas are we comparing? Reasonable prices to atmosphere. So price versus atmosphere is the question. You guys following me? Okay, now yours again might be different. So price accounts for 20% of the respondents. Of the 1,500 people who responded, 20% felt that price was an important component. Now atmosphere is right here at 12%. Now there's a couple ways to do this. You ready? Method number 1, get the amount 20% of 1,500, 12% of 1,500, subtract the two numbers, that's your difference. What's probably a little bit more efficient way? What's the difference in their percentages? 8%, isn't it? The difference in their percentages is 8%. So all I have to do is multiply 1,500 by 8% instead of doing two separate problems and then subtracting them. I know that they're differing in 8%. So all I got to do is take my total, multiply by 8%, and that's going to be the answer. You guys follow me? Yes, you can multiply 1,500 by 20%, 1,500 by 12%. Get two numbers of people and then subtract them and you'll get the same answer. But why work extra if we can just take the difference in percentages and multiply? You guys follow? Can somebody do that math for me? 1,500 times 0.08. You want to do that for me? It's going to be what, 80, 40, 120? Is it 120? Somebody want to do that for me?
You said times, right?
Yep. $120? You could do it.
Yeah, 120.
120, great. Okay, so 120 people. And there's the difference. Makes sense, everybody? Hopefully you got your question correct. and I can type this in. There we go. Okay, good. Everybody got theirs correct? Anybody want me to do their problem? You just let me know. Happy to help you. Good. All right, let's move on to the next one, shall we? Okay, number 9. So on number 9, it says, this bar graph shows the top 6 reasons in percents why people say they ride a bus. Use the graph to answer the questions. Okay, what is the second most popular reason why people say they ride a bus? Well, looks like, again, I don't believe that you even need to look at this graph, right? You can use the percentages here to help you make a decision. And thankfully, they've ordered them greatest to least, biggest to smallest. So when they say second most popular, looks like this is the second most popular, which is to lower the pollution. So there it is. What percentage gave this reason? Well, it's as simple as just selecting the percentage that's next to it. Any questions about that problem? We okay? You guys doing all right? Okay, fantastic. Let's go to the next one. Number 10. This bar graph shows the top 6 reasons in percents why people say they eat at JJ's. Use the graph to answer the questions. All right, what percentage of people say they eat at JJ's to eat at Clean Tables? Well, Clean Tables is down here, and it's associated with 50%. If 700 people were surveyed, how many gave this answer? Well, this is very much like the other problem, isn't it? Where if you know the percent and you know the number of people that were surveyed, then all you have to do is multiply the people by the percent. Of course, you probably want to convert it to a decimal, and this one's easy. Just half of them for mine. Yours might be different, right? Like if yours is 37%, it might be a little bit more difficult to calculate, but you can go and do that by hand, okay? And so 350 is the total number of people that go eat at JJ's because they like the clean tables. Got it? Questions? Anything I can help you with? All right? Shall we move on? Next, the double bar graph shows the number of workers who were unemployed in the city during the last 6 months of 2010 and 2011. Use the graph to answer the question. Find the amount of decrease and the percent of decrease in the number of unemployed workers from August 2011 to December 2011. All right, this is actually, or can be, a little bit difficult, but I'll show you how to do it. First, know what they're asking. Actually, it's 2 parts. Amount of decrease is the first part, and then percent decrease is the second part. You follow me? Okay, it's a 2-part problem. Now, before you can even answer that, you have to know the period that you're reviewing for the decrease. So my period is August 2011, which would be right here. Oh, right here, and it is this line because 2011 corresponds to that color. You guys with me so far? Okay. So what is that? That looks like it's 10. And that's in the 10,000s. So that would probably be 100,000 people. Okay. We'll take a look at that in a moment. See, because that corresponds to right here. Okay. Now they said to December 2011. Now again, my problem is referring to 2011, so I need to look at this bar, which corresponds to 7, and remember that it's in 10,000s. So 10,000s means that this gets multiplied by 10,000, which means 70,000 people were unemployed. This gets multiplied by 10,000, which means that 100,000 people were unemployed in that city. Do you guys understand? Okay, so that's just something so that you understand context. So 100,000, 70,000 between August and December of 2011. Let's recap the just setup part of this problem, because like I said, this can be a little bit tricky. Number one, know what they're asking. Number two, know the time frame that you're needing to be reviewing. Once you do that, and you know the time frame, pay very close attention to the year. If I pick 2010, I would get the second part wrong. They match up here, but my 2010 is very different from 2011. So pay attention to the color that is associated with the year that they're referring to. Then finally, make sure you write down the correct amounts associated with those periods. Got it? That's just the groundwork. That's just the basic layout of the problem. Now let's actually answer it. The amount of decrease. So what was my decrease? Well, I went from 100,000 people that were unemployed to 70,000 people who were unemployed, which is a decrease of 30,000 people who were unemployed. That's a good thing, right? Less people that are looking for jobs. Okay, makes sense, everybody? Questions? Please ask. Now, the harder part is percent of decrease. Now, in order to do percent of decrease, which like we said is the second part up to this problem, you take the amount decrease and divide it by the original. What do I mean by amount decrease? Well, that one's clear. We decreased by 30,000 people over that period. With me so far? What was the original start to the period? August, which is what? 100,000. Do you guys understand? So you go back to your original number, and that goes on the bottom. That's your denominator. So it's not going to be your ending. So I would call this, say, you can call it the original, you can call it the starting point, okay? And then you can say the ending point right here. So original starting point, ending point, you go back to the starting point, if that helps you understand it. What did you start at? Follow? Okay? And then of course you can simply simplify that fraction. I can cut off some zeros, and that's going to be what, cut off 4 zeros, be a little bit careful, I was sloppy there. So that's going to be 3 over 10, and they want it as a percentage, so that's actually what, 30%. Okay, I mean, you could have just done the math off to the side, but the other thing to note is that if I had cut off only 3 zeros, it would have been 30 over 100. You guys follow? And what's 30 out of 100? 30%. Whatever. You get the idea. Okay? Make sense? All right. Questions about that at all? Can I help you with anything? Hopefully we're moving nicely through our homework. Good? All right. Okay. That was kind of a tricky question. Lots of details involved that you have to know. All right. Let's go to the next one, shall we? Okay. About how many alcohol-related deaths occurred in 1993? Well, let's go take a look at this. 93, so I need to hone in on this year. And I'm going to come up to this point, and it looks like that point falls somewhere between 17 and 18. You could almost say that it's like a 17.5. Everybody agree with that for mine? Any questions about that? You guys understand where I'm getting that from? Here's 93. It's right about there, 17.5. And remember that this is in thousands, isn't it? How did I know that? It tells us. So that means that if I multiply that by 1,000, that is going to give me 17,500. I do it the same way as I did the last problem, right? In terms of converting it. So it looks like 17,500 is the correct answer. Any questions about that one? Make sense? You okay? Ready to move on? Questions? Okay, all right. Next. All right, next one. This line graph shows how the personal computer has evolved over 3 decades of its existence. Find the number of PCs sold in 1995. So just like we've done in previous problems, go identify where they're looking or wanting you to look. And it shows that we have 64.8. That's the nice thing, is it actually gives you the number. Now remember that this is in millions. So 64.8 times a million, it would be actually your answer. So just be aware of that. How many places would you move your decimal? 1, 2, 3, 4, 5, 6. So how did I know that? Because there's 6 zeros in the million. So if I put my placeholder there, that means there were 64,800,000 computers sold in 1995. Okay. So, but I don't think they even asked to do that. I just threw that in there. And there it is. You didn't even have to convert it. Does that make sense, everybody? I just want to show you how to read that, just like the previous 2 problems. But you didn't have to do that. They just wanted you to identify 64.8 million. But if you didn't know, that's what it is. 64,800,000 computers. Okay, next. Almost done. The graph to the right shows the median prices in 2 cities for homes. What was the median home price for each city in 2003? Let's take a look. Here's 2003, 231, 140. Now, they say that this is in thousands. That means that the median, the middle home price was $231,000. In this city, the blue city, city B, the median home price, the middle home price is $140,000. Follow me? So the median home price in city A, the red line graph, was $231,000. I think they actually want you to write that. Follow me? You actually have to put down the zeros. Don't put 231. That would be wrong. What's the median home price in city B? Not 140, but 140,000. Good job, everybody. Oops, and I just messed that up. I missed my zero. Be careful with your zeros. Good job. That's it for that one. Okay. I'm going to leave 15 all to you to do. Okay? It's just like the other ones. All right? And that will do it.